If you make products with moving parts, here's a great new application that will help you answer two questions. First, what will the product look like when it's moving, and what are the kinematic properties such as distances, accelerations, and interferences? Let's analyze this free body sketch of a suspension in Animation Designer. Watch as we quickly define the motion between components using mechanical joints that simulate real-world conditions. A fixed joint locks down what components shouldn't move, such as the suspension and frame, and a revolute joint will allow the wishbone to pivot about the frame. Notice the minimum number of inputs. We only have to define the joint, but other operations such as rigid group creation are done automatically. Rigid groups tell the system what can move but are being created during joint definition. This automated approach is perfect when defining the motion of a small assembly. A spherical joint will simulate how the wheel pivots around the wishbone, and to simulate a bumpy road, we'll slide the curve back and forth. Finally, we'll connect the road to the wheel. Let's check our progress by running the animation. A fast solver in Animation Designer gives results instantly so you can try different scenarios in less time. Now let's automate motion by moving the ground. Let's add a motor that will slide the road back and forth. We'll add an event to move the road in one direction, then another event to reverse that direction, and a final event returning the road to its initial condition. You can have as many motors as needed simulating very complex operations. Once complete, motion is transferred through the suspension components, causing it to move up and down. The behavior looks correct, but if any changes were needed, we would simply access modeling and modify the sketch. Now we can determine the shock travel by adding a measurement between parts. You can add linear or angular measurements that report displacements during the animation. A built-in graphing function will report the measurements so you can visually see critical characteristics such as maximums, minimums, and points of inflection. Within a few minutes, we have identified the travel required for the shock absorber. Animation Designer in NX12 is a perfect fit for designers that need to see their products in action and understand kinematic properties such as distances, velocities, and accelerations.